Hello guys, welcome to this video. I want us to show that the sine inverse of any complex number is given by 1 over I times the natural logarithm of sin z plus the root of 1 minus z squared. Now, this formula will apply to any of the complex number you know. Z represents any complex number. Now let us look at the solution. How should we show this equation? Solution. Now, if W is equals to sine inverse of Z. Now we let W to be sine inverse of Z. Meaning that if I multiply both sides by sin, remember if I multiply sin inverse with sin, I'll get 1. So this place will remain with Z. So I can say Z is equals to sine W. Is it correct? Yeah, very correct. But now recall from this guy called Euler. The Euler's formula, we have that sin W, yeah. But now Euler uses theta. But W is any variable. Sin W is equals to exponential IW minus exponential negative IW all over 2I. That is sin W. Remember this sin W is equals to Z. Are we together up to that point? Now we want to multiply both sides by 2i, meaning I will have exponential IW minus exponential negative IW minus 2iz is equals to 0. This one we can just disintegrate it as we multiply both sides by exponential IW, or we multiply by exponential IW. Exponential IW times exponential IW, you get exponential IW squared, which is the same as exponential 2IW, which is exponential IW squared anyway. Minus, remember, negative IW plus IW get 0. This one exponential raised 0. Then minus 2iz exponential IW is equals to 0. Are we together up to that point? This is 0. Yes. Now remember the law of indices. Any number, say 100, a million raised to 0, is equals to 1. So this implies that this is exponential 2AW minus 2IZ exponential IW minus 1 is equals to 0. Now this one becomes like any other quadratic equation. This one is a quadratic equation. Now the most appropriate way to solve this quadratic equation, we use quadratic formula. We will proceed to use quadratic formula. You remember the quadratic formula? You know your A, you know your B, you know your C, all of that. So let us proceed to use the quadratic formula. So it becomes minus, there is another minus 2iz, that is actually my B, plus or minus root B squared, this is my B. So I will proceed to use it here, which is minus 2iz squared minus 4 times 1 times minus 1. That's it. Yeah? This root is equal to root over 2a. Remember my a is 1, so it is actually 2 times 1. This will give me exponential IW. Correct? Yeah, very correct. Now from there, we will proceed to get to solve what is inside the bracket. This becomes negative times negative, we get positive. This is 2iz plus or minus. Correct? It's plus, plus or minus root. This actually becomes, when you operate this side here, it becomes 4. 4 positive minus, this is 4z squared all over 2. Remember 2 times 1 is just 2. Yeah. This implies that, in fact, this gives us IW, which will be, remember I can just write 2IW, 2iz over 2, yeah, plus or minus. Remember, here I can just write root 4 times root 1 minus z squared. It's just the same thing. Over 2. Just the same thing. This implies that my exponential NW will be this one will cancel. Remember, this one will just cancel very easily. Nz plus or minus. Remember, root 4 is 2. Root 4 is 2. So 2, 1 by 2 is 1. So which gives me plus or minus root 1 minus z squared. But now remember, there is something here I want you guys to remember, that exponential NW is equals to, I can just stand right exponential I outside, W minus 2 pi k. Remember, the W is periodic, it is changes. I want to do away with this plan. I just want to do away. Oh my goodness, it's becoming is actually plus or minus. I just want to do away with this minus here, just to plus. So I'll write exponential into represented that W minus 2 pi k, of which where k can be 0, plus or minus 1, plus or minus 2, and it continues. Meaning that my exponential NW will be Nz plus root 1 minus z squared. I just want to remain with W. Remember, my W is equals to sine inverse of z. So if I get the value of W, this one, I will just have gotten the value of sine inverse of complex number, which is z. Now multiplying both sides by ln, and we have natural logarithm of exponential IW is equals to ln of everything in this bracket, that is Nz plus root 1 minus z squared. Yes, correct. So from there, what we are scheduled to do is that, remember, exponential will cancel with the natural logarithm. So we have IW is equals to natural logarithm of Nz plus root 1 minus z squared. Remember, if I get W, remember W is equals to sine inverse of z. If I get W, I will have gotten the inverse of a complex number. So if I decide to define both sides by I have W is equals to, okay, just a minute. W is equals to 1 over I of everything, natural logarithm of Iz plus root 1 minus z squared, which clearly dictates that this actually W is equals to sine inverse of z, which is equals to this one. So this one is actually the sine inverse of n complex number. Thank you for watching this video. Please don't forget to subscribe to the YouTube channel. Thank you.